Close. Stop. Very close though. For today, it was like I was trying really like Is it Adam Rios here? Is done. James Johnson. And Aaron left. Might not have said the last one right. Okay. Everyone turn it in who wants to turn it in? Oh. Okay. Should we get started? No, it's 1 minute early. Have to wait 15 seconds. Okay. I'm trying on here to, if you watch the last recording, I think 2 people did, but that could have just been random people on the internet. It like recorded my view and not the view that's shown. So if that happens again, I'm sorry, but I don't know. We'll try. Hopefully everyone is able to turn in their homework who wants to. We'll talk a little bit about my expectations for the class and the homework today and how you'll see your progress updated on Canvas. Someone mentioned that this looks like Stonehenge, fairly close. These stone circles have been seen around the earth for a really long time. Remember that we were talking about the fact that ancient people didn't have watches, right? So I could tell that class was supposed to start because of this handy dandy gadget. And we can talk about the history of watches if you're curious why they were created. But this would be a modern equivalent of the thing that took care of your calendar. You say, how the hell does that work? So you have all these stones and you stand in the middle of it. And throughout the course of the year, the sun is going to rise and set in different parts of it. And so I'm going to challenge you to do this year. You don't have to do it every day because that's insane. No one wakes up before. Anyone wake up before dawn? Oh shit. All right, never mind. Okay, well, you guys have the opportunity if you want to Find a place in your house. Look for where the sun is setting. Look for where the sun is rising. Just once a week for 15 weeks. Mark it. Like if you have a window, literally put a little piece of Sharpie, right? Just mark where the sun rose that day. On the window, yeah, because you can wipe it off. Never wiped Sharpie off of glass? Super easy. Okay, and if it's not easy, I'll give you a little squirt bottle with the squeegee. Okay. And what you'll notice is the sun's location is going to move with respect to the background. So that's what this is going to be talking about. And we'll demonstrate why that's happening today. Okay. So what makes a part of your grade? So hopefully everyone's put in the homework and they already answered that first question. But if you want more details, this is what is going to go into your check-ins. So I had someone ask about whether or not they're essays in the class. And essentially there kind of are. You're going to be describing why you deserve the grade that you do. And we're going to base it on this type of a metric. These are the things that I expect from you. And then you're going to have your own expectations as well. This part here is the preparation. This is the hardest thing for me to obviously assess because you can do it after class, you can do it before, but I kind of get the feeling for it based on your engagement, right? Participation in class, that means attending class. So that's tracked through clickers. Clicker questions, are you participating in all of them? Right? Do you click once? Right? Do you feel like you're really getting the material? I don't care if you got the wrong answer. Right? I really don't, because that's the process of learning. You get the answer wrong, you try again. My thing is, are you, engaged with the material? Are you turning to your neighbor and having an honest conversation about what you know versus what you don't know? And then we're going to do something today called the lecture tutorial. That'll be fun, I promise. You also won't be graded on what's in there, and there are no solutions to what's in there. So this is like a place for me to look at your answers and get a sense for whether there are misconceptions or maybe something that's not being understood as a whole that we can work through. And we'll talk about that in more detail. And then hopefully everyone turned this in today. Okay, that's here. And if you turn it in early, I like that. I can give it back to you right away because I just graded it really quickly. You can attend student help sessions, and I'll have a clicker question about this at the very end. Hopefully I remember. Just showing you all the ones that exist. And of course, there's extra credit if you can attend 12 of the weeks. Between 8 and 12 has a smaller bonus. Cool? Okay. I'm going to ask you to think about your educational goals and whether you're achieving them over the course of the semester. We're going to have 3 check-ins. They're going to be 5 weeks apart. So this is week 2. So you have, this is week 2, right? Yeah. So we have 3 more weeks. In that 5th week, you will prepare this. So in 2 weeks from now, you'll submit it that Thursday. Okay? Okay, we'll talk about it more. Each unit, so this is not my word, this is what the university says. This is a 3-unit class. So every unit of credit presumes 1 hour of class time, like we're doing right now, and 2 hours of preparation over the course of 15 weeks. So not quite 15 weeks, it's a little longer. So you should be expecting to spend somewhere between how many hours outside of class per week? Outside of class. Yeah, like 7. Okay. How long did the homework take? 7 hours? No. Okay. So what the rest of that goes into is that goes into reading the book. That goes into any office hours, coming up with questions, taking that onto yourself to spend the rest of that time. You can not spend it at all, right? That's your prerogative, it's your time. But since you pay for the credit hours, you may as well get the learning, right? I don't pay for this. I get paid regardless of whether you learn. I want you to learn, right? Okay. Everyone who turned in homework, good. You didn't turn in homework, bad, but not the end of the world. So there's some folks who couldn't make it, right? So their cars like broken or they have COVID, like don't come in. They're deployed. You can't come in, right? So if you don't have an excuse, I won't accept it. It's that simple. Okay, just tell me ahead of time. I'm very understanding, but I need to know ahead of time. If you're in the hospital and unable to communicate, that's fine too, right? That's a different example than like, oh, I forgot, right? That's not an acceptable answer. The assignments are going to be tracked in the grades portion of Canvas. So that just shows me whether or not I got them. So you're just going to have zeros and ones. Did I receive it? 1. Right? Not was it good? Did I receive it? Right? The feedback is going to be the stuff that I write on it. If there's no number, that means that it was excused. You told me ahead of time and I'm still waiting on it. Okay? 0 means it wasn't there. Questions about that? Same thing will be true about the lecture tutorials. If I pass them out and I don't get yours back and you see a 0, just be like, yo, I gave this to you. It's here. Then I'll look and I'm like, oh, it's right there. Right? Yeah.
You still turn homework in person?
I prefer in person so that I can write on it. If I get 80 versions, then I have to print 80 versions, or I have to look at 80 emails. Because if we want to do it fully online, then we would use Gradescope, and Gradescope is not as easy to like write which specific line or which portion of your response I thought was good or important. Right? It's much easier to mark through something, say this was not good, underline something, this is great. Right? Those would be my different markings. Scratch through, incorrect, underline. And I'll usually write in the margins. Okay. Clickers won't be tracked on Canvas. I'll try and post every couple of weeks. Like there's that spreadsheet that has your clicker number on it. Only you will know how your own clicker progress is going. Okay. Yeah.
Not that I would lost it, but I don't have access to my clicker for like for 3 weeks because I left it somewhere where I don't have it right now. But what happens in that situation?
Just signing, I guess.
Okay.
Yeah. You still participate, that's fine. Right? This is not like if you don't show up, you're gonna fail. Right? It's like, you just go back one. Are you attending? Are you engaging with the material? Right? Cool. Everyone agree? Okay. Content. So I told you you had to brush up on flags. People look for their flags they got home. No, everyone immediately forgot, right? All right, which one's which? What's the easy one? Brazil. Okay, everyone got Brazil now. Good. Australia's top left?
Yeah, we're top right.
Yeah? Top left. Okay, good.
Feeling top right, right?
Why?
Because they're near each other.
Because they're near each other?
I know because the stars is fairly wide.
Because they share a very similar history, right? What's the difference between New Zealand and Australia? Both colonized by the English, hence the Union Jack. Both in the Southern Hemisphere, great. One of which has nothing that will kill you. Really great. And one which has the highest density of things that will kill you. You know which is which? Australia has so many spiders that'll kill you in so many disgusting ways, a ton of venomous snakes, and New Zealand has none of them. New Zealand doesn't even have mosquitoes. I think, pretty sure. Double check me on that, but I'm pretty sure that's true. Okay, awesome. Good job. This one. Papua New Guinea, very good. This one? Samoa, good. American Samoa? No. Not American Samoa. American Samoa is a territory or colony of the US, and this is the independent nation. Okay? Cool. We were talking about daily motion, right? And we were thinking about this like weird imaginary sphere that goes over our Earth. And this is a construct, it's not a real thing. It's a way for us to understand the motion of stars on the sky. So if you could see during the day, for example, you would be able to see stars. Sorry, if you could see the night sky during the day, you would be able to see the stars right next to the sun. You can't do that for reasons that we'll talk about when we talk about atmospheres. But you might have these constellations like Taurus, Great One, Gemini, And you might see them throughout the sky, right? And throughout the course of the year, they're gonna move, right? So in a day, let's say you have this picture with the sun rising against those background stars, if you could see them. Is there anything wrong with this picture? Yeah, well, let's imagine that you could see the stars next to the sun. Yeah. The constellations haven't. Oh, that's very interesting. What does that mean?
Yeah, everything slowly or they don't come out.
Yeah, so why haven't so we're asking what's wrong with this picture? Do we expect the constellations to be there? No. Why not?
You turned away from one that itself is moving.
Because it's our motion, not the sun's motion. The sun's motion on a day-to-day basis is chilling, right? It's the fact that we are rotating that makes everything in the sky appear to move. So if I could see the stars during the day, they would be different stars than I saw 8 hours earlier. Does that make sense? Okay. All right, first one. Let's go. I brought it this time. All right, hold on, wait. Let me open it. Okay, so let me read it in. What about the sun? What causes the sun to rise and set? Is it A, the Earth's orbit around the sun? B, the Earth spinning on its axis? C, our solar system moving in the Milky Way galaxy? D, the sun's movement around the Earth? And E, not and, sorry, the Earth changing its axial tilt. Uh-oh. I'm not getting any answers.
Yeah.
The base is right here. What the fuck? Hey, hold on a second. That's exactly what I'm gonna do. Oh. Don't break everything for some money. Does it say no base still? Oh my god. Classic. No worries. Then it says base connected. Start class. Oh, there we go. Okay. Order of operations. I need to repeat it or you guys got it? Okay, 55. Anyone not click in who thinks they clicked in? I guess we'll find out. 57. Okay. Majority of you have the right answer, but a few do not. Does anyone who thinks they have the right answer want to answer? Why?
Earth orbit around the sun in the year.
Oh, interesting. Okay, okay. So why is it? So what is it about B that causes the sun to rotate? Yeah, Earth spinning on its axis instead of
Basically like.
right. Yeah, okay, perfect. So like we had this analogy where the Earth was the fist, you guys are all the sun, and like you said, the swivel chair rotates, and that shows different parts, right? For example, if I rotate, now I can't see part of the class. They're in sunset, you're at noon, now it's nighttime, right? Okay. We use our bodies, it helps, I promise. It's like weird spatial thinking. So like use your hands, use your head, because like that's how you see, right? Like it's very natural. Okay, so let's go. Oop, excuse me. Come on now. So we're just gonna finish off this discussion of why the sky looks different at different latitudes. Okay. Do we know what latitudes are? Yeah, good. So here's the Earth. You are here, roughly. Notice that when you put it on a globe, Greenland gets really small. And Greenland's not massive like you've seen on flat maps. No. Okay. Here's the equator. Going through Ecuador, we talked about that. And if you break it up with lines that are parallel, those are your latitudes. So they go between 0 and 90. The North Pole is 90. And we're like here, so we're like 36 or something, 42. I forget exactly. Rome's in. And then there's the meridian, the prime meridian, goes through both Paris and London. Guess why that is? Colonialism. Come on now, let's be real. Okay, so they were there, they're like, this is the center of the earth. Okay, it's arbitrary, we just keep it. Well, they argue about where it starts. So each one of them believes that it starts there and everyone else is wrong. Okay, so latitude is the position north or south of the equator, and longitude is east or west of basically London or England, depending on who you want to believe. Okay. We use the Greenwich system that goes through Greenwich. Cool. All right. Is this at the North Pole? Yes? Is this picture taken from the North Pole? You don't think that's like Santa's? Okay, yeah, that's true. Actually, depending on the time of year, right? Okay. North Pole doesn't have a land there. So maybe that's a giveaway because of land and people. What else about the rest of the picture tells you that it's not the North Pole? Could it be the South Pole? Yeah.
As we can see the stars beneath the horizon, that means we're staring at the north from here. So we're looking north of the mountain.
Okay, yeah. So that's like you see that they're setting, right? And you're basically saying that because you see any stars setting, you can't possibly be at a pole. Is that right? Okay. Well, let's imagine how we would think that through, right? How would the night sky look from the North Pole? Let's try this again, see if it would work. What would the night sky look from the North Pole? Would A, all stars be circumpolar? B, no stars would be circumpolar. That is to say, everything would rise and set. C, it would look exactly the same as it does here. D, some would look circumpolar, that is to go around the pole. Some normal, but some would be different stars than San Bernardino. Everyone wants to vote? Oh, someone changed their mind. Interesting. All right. An option that's not present. Nope. Okay, they disagreed. All right. So we have two camps. Some folks like all stars would be circumpolar, and some folks love some stars circumpolar, some normal, some will be different stars than San Bernardino. So I want you to find, if you're A, I want you to find someone who believes D and try to convince them. And if you're D, I want you to convince someone that you find about A. Just for like 3 minutes. Okay? And then we'll try it again. Okay, you can buzz in when you're ready.
Yeah, good.
Buzz in when you're ready. You've convinced your partner. Let's find out. It's much more even now. That's interesting convincing. Only about half of you have buzzed in now. You can, well, I opened a new poll, so you can click in now. That's why I said buzz in. When I do that, that means put the answer in. I don't know. Is there a different way I should do that? No, because then it's gonna be embarrassing after do clicking sound. I'm happy for the back. I'll do this. No, that's okay. Okay, all right, interesting. Anyone wanted to defend their decision here? Yeah.
Oh,
What did you pick first?
I picked A.
Picked A. Okay.
So since like what time of the year it is, the sun's either always going to be hitting the North Pole or sometimes it's not always going to be hitting the North Pole. Since there's not very much movement up there, it's at the very top. I feel like the stars wouldn't really move on too much. They kind of just stay where they're at, and we wouldn't see any different stars because it's always going to be they're always going to be looking up.
Okay, let me see if I'm tracking you here. So we have all these stars, right? And let's say you're all stars, you're all individual stars. And I am looking, let's say I'm in San Bernardino, I'm rotating. So all of these stars are rising and they're moving over my meridian and then they set, right? Is that what you're saying? But if I'm at the North Pole, and it's like this, and I rotate around the pole, so I just see all of you move around in a circle. Is that reasonable? Okay. So A is correct. All right, let's try it again. Next one. Using what? Yeah.
Some normal stars, that means that some normal stars did set, I'm right.
Yeah, so that would be like, so if you stand exactly at the North Pole, no star will rise or set. Here, you have what we call like normal stars, like stars that are not circumpolar, that rise, and then they disappear, and you don't see them. Whereas right now, if you go and you take a long exposure, even here, you'll see those little circles like we saw in the Utah picture, right, or the one that we just saw. Those are special stars. Those are circumpolar stars, stars that go around the pole. Circum meaning around, polar meaning pole. Okay? All right.
You're saying they stay, circumpolar means they stay, and non-circumpolar means they go away, right?
Yeah, circumpolar means that they don't set. So for example, if you stand right at the North Pole, for example, if you watch the sun, say it's like early March or something, the sun just doesn't rise and set. It just goes around in a circle around the entire horizon. It's really freaky looking. I'll find pictures of that. I'll show you on Tuesday, where it's like the time lapse. It's just following the sun and it doesn't rise all day.
6 months of sunlight.
Yeah, it's crazy. I don't know how people live there. Okay, not me. All right. What would the sky look like from Ecuador? A, all stars would be circumpolar except possibly Polaris. B, no stars would be circumpolar except possibly Polaris. C, exactly the same as San Bernardino. D, some circumpolar stars, some normal, but would be different stars than San Bernardino. Almost there. 43, 47, 48, 52. Okay, a lot of folks liked B. Anyone who liked B want to explain their answer? Someone who hasn't talked today? Just give other people voices. Yeah.
All of them be considered, none of them.
Right. Yeah. That seems exactly right. So if I stand exactly on the equator, everything appears to rise in the east, and then it all sets in the west. And even if I look at the pole star, Polaris, it is not exactly at the pole. It does that little circle that we saw in that picture. So it'll in fact rise and set. But you will see, of course, southern stars, which is cool. But none of them are circumpolar, exactly like you're saying. Cool? Okay, final one, and then we're gonna do the lecture tutorial. Okay, hold on. Don't do this one yet. Let me just read it, and then I can reset it. Okay. Which way will the stars appear to circle the south celestial pole from Tasmania, which is in Australia, when looking south? Is it A, clockwise, B, counterclockwise, C, depends on the season, D, there is no south celestial pole, so there'll be no circumpolar stars? $36, 41, 44. Okay, all right. Interesting. Interesting. Um, Which direction do stars rotate now when facing the north? And how would you figure that out? Yeah, I see some people's hands. That's great. Right? Like if I start with this, that might be a good way to do it. So stars rise in the east and set in the west, right? So if that's the north, rise in the east, set in the west. Now you can do that, just pretend this is north. That would be east and that would be west. Don't shout it out, but think about that and then see if you want to change your answer. Okay. Okay, let's think this one through. If I'm looking north and they rise in the east and they set in the west, let's do it all together. If I'm looking north, they rise in the east and they set in the west. Which direction is that? Counterclockwise. Good. All right, now I'm looking south and they still rise in the east and they set in the west. So that is okay. Good. Does that make sense? Is anyone confused by that? Yeah.
I don't know clockwise and counterclockwise. So
Oh,
you're like-
we don't have clocks in school anymore, they're all digital.
That too, but
Yeah.
it's like, I tried to visualize like a.
Yeah. It's okay. That's okay. So clocks, just think about the like, so right to left, more or less. So just like we read, sorry, left. How do you say right to left? Left to right. Right, yeah. So think about it just in terms of like how we read right to left. How we read left to right. To start at the edge and then go that way. And so the same thing, but then you just follow it around. That's clockwise. Oh. Yeah. And you can see it there. That's for reference. Okay. Cool. Okay, so let's try a new activity. Just to cement this thing in our brain before we get into like how planets move on the night sky. So these are lecture tutorials. You will need a friend. Okay, take a friend, introduce yourself. You will share one piece of paper. You will work with that friend on this. Wait, hold on. The questions build on each other. Okay, so take one and pass them down if you don't mind. One between two people, ideally. I think I printed enough. The questions build on one another. So if they seem too easy at the beginning, that's because they're exactly what you think they are, right? Just like make sure that we understand the basics and then we build on it, just like you saw there. Okay, how long does a picture take? What direction am I looking, right? There are no answers for this. That is to say, this isn't something that I'm trying to get you to memorize, like exactly how this works. But you may see very similar questions, say, in the homework, right? And then, of course, their solutions would be posted. We're going to have two LAs walking around. You don't want to talk to me because I'm scary or anything. Just raise your hand and be like, that person instead, right? Okay. No such thing as dumb questions, right? You only need one. Only one per pair. And just go ahead and put your name on that. That will help me. Name, last name. Name, last name. Yeah, that's right. Is Aaron Gillespie here? No.
Yeah. You kind of look like.
Okay.
Right?
Yeah. Is that yours? Yeah.
No, but.
No, go for it. Yeah, okay. Been there for a week, so.
And again, you're getting together for the year.
Okay, so we're gonna. Yeah, rather than further reading, write together, you can write separately, and read back and forth. Ideally, don't let just one person do all the work. Right? Like a nice, kind, collaborative effort. If you guys want to talk about better to do a brief sentence.
Yeah. Yeah, no, like Burpee's thing, yeah, just right.
Oh, yeah, can I have that? Yeah. Is there any extras or folks in the back who don't have one? You should not be one person working on it. Got a one? There's just people who don't have. Anyone not have one? Yeah, yeah.
You go highlight, right? You go highlight.
Whatever you want. That's good. Make sure your name.
If they were in a school to rise.
Right.
Yeah, there's not like that.
You ever look at the homework? Fun, right? That's great. Well, some of it will be very similar to what we did in class, you know, and just like part of it. Yeah. And we'll do them only when it's not just immigration. So, you know, I'm setting up the integrals and what's important thing for me. Doing the integral, you can do that all day. Right? As long as you know how to set it. Because I know that you don't necessarily need to do an integral for the rest of
Yeah, because like the way they're different, like. I think so, yeah.
Think about finding
Yes, I mean, so we like geology. It's a great department, you know, so they have an acquisition department, right? It's usually different than geology. The core curriculum is great. It needs physics. So, one thing that they were gonna look for is things like people taking we take quantum. Right? And if you haven't taken those, I would suggest looking at geology because you still can work for a lot of things in science without having to take the filter.
Yeah, definitely.
You want it out.
Yeah.
So if you choose that to be north, then that is. But if I'm choosing not to, then that's.
I'm new to the class. I'm going to say the class.
Oh, yeah,
Yesterday.
Yeah.
I need to
Click it. Oh, yeah. You mind?
Yeah.
First read that.
Okay.
Oh, yeah. And then there's stuff online. You were able to get into Canvas already?
Yes.
So that'll have all the past information we did last week, that was on Tuesday, and then all the lectures you do recorded. Oh, yeah, that's okay. Why did it send me, just let me know that you're doing this right now, just like, oh, sorry about that, and then you can print it on. Okay? Yeah. Folks, how far are we? About halfway? More than halfway? Less than halfway? About halfway. Almost done? Star pupils. Okay, let's give it about 5 more minutes, and then regardless of where you are, we'll stop and we'll continue with the rest of the lecture. Okay? You won't be penalized for it not being done. Okay. What? It's like a photocopy. Yeah.
If it was not.
Oh my God. I tried out to think about it like that. My he loves just every so
Okay, one more minute.
Oh, yeah.
You can leave if you need to leave. You can leave if you need to leave. Yeah. Okay, folks, let's wrap it up. If you are done at the end of class, go ahead and give that to me. Don't do it while I'm talking. I prefer for you to just hold on to it. The reason that I like this activity is notice how everyone was working together. Good. Learning happens together, right? So if you want to exchange information, if you want to work on homework together, good. I like that. Collaboration, good. Okay. If I get ones back this time that just have one name on them because you didn't get paired off, that's perfectly fine. But in the future, that won't be fine, right? Unless you are doing them at home because you have COVID, you should be working with someone else. Okay. It shouldn't be larger than 3 people, right? Because then you're just not doing anything. You're just listening, right? Conversations with 2 people are best. That sound good? Okay. So far we've been talking about daily motion, rising and setting, right? But people have been looking at the sky for a long, long time. And so we're going to talk about now annual motions, and we're going to talk about how the planets move as well. That's different from the daily motion. And I told you that this is the prove it to yourself. So I can offer also extra credit if someone wants to do this. Once a week, take a photo where the sun rises. And notice 2 things are going to happen. It's not going to be the same place. And weirdly enough, it's not going to be at the same time. So you can explain why that is. Okay, cool. So for example, I try to do this every year. Doesn't really work because sometimes the sun sets before I can do it. So if you can do it, it's great. But if not, it's
It's because of the solstices and equinox, right?
Sure. Yeah. But we want to explain. I mean, so that's words of that's how we perceive it here, right? So we see that it's moving, and solstice means to come to a stop, and then it comes back, and then you have equinoxes, which are equal day, equal nights. And then you have another solstice where it stops. But why is not just the words, right? It's also like, what is it about the system that's changing? And we're going to see that in a couple of seconds, okay? Yeah. Okay. So let's talk about annual motion really quickly. The sun appears to move. Now, this is annual, not daily. Sun appears to move a little bit each day. So the reason that we have these zodiac symbols that we associate with our birth is not because that is the zodiac that was up at night. It's actually where the sun was in that constellation when you were born. Constellations are big, obviously. So there's a range. And I'll show you a picture of that in a few seconds. This is that same weird thing that we did at the beginning. If you could somehow see stars while the sun was up, right? You would look up and you would say, oh, the sun's up and it's in the constellation. Well, anyone have a birthday around now? Yeah, what zodiac are we in? Virgo. Okay, so if you looked up, you would see stars around it and it would look like Virgo. So like we're in Virgo. Whereas in May, if you looked up, in May 19th, you look up, you'll see Taurus. Right? Make sense? Okay. If you want, this is a fun one. You can like download a planetarium. There's one that I put in Canvas. That's Stellarium. This one's also fun. You just like orient around, look at what it looks like. You can change the time of year. You can turn off the atmosphere so it looks like night all the time. Pretty cool. Okay, so this is the picture. This is the apparent motion. So what I mean by that is this is how it appears to us. We're here, obviously, center of the universe, right? And it looks like the sun moves through the constellations. All these don't move. All these constellations don't move. And it looks like the sun goes around us. Okay? This would be what we call a geocentric view. Earth center. Geo being Earth, center. Okay. Okay. This plane is the word ecliptic. That's the plane in which the sun orbits the Earth, right? Is the sun actually orbiting the Earth? No. Okay. This is how it appears to us. Apparent, right? Similarly, if we take a planet like Mars, it appears to go around us as well, right? It moves through the whole zodiac in 2 years. So which one is going faster around us? The sun. Okay. Sun takes 1 year. This thing takes 2 years. Okay. That's how we interpret these things.
Why is that? Why is it?
We'll get to that. We'll get to that. Good question, but we'll get to that. Okay. So let's look at some scientists. We're going to break them up. You don't need to know the numbers. You don't really even need to know most of the names, but there are 2 groups of thought here. Okay. These are the Greeks, and these are the folks who participated in what we call the Copernican revolution. And the reason that I'm bringing this up at all is to go back to that idea of what do we do when confronted with new information? How do we adapt our theories and understand them better? So, for example, we said that people have been watching the sky for thousands of years. Okay? And these folks are 3,000 years older than the pyramids. We know the pyramids were built with really great precision. So they had pretty good ideas. And they had fairly good instruments for watching the stars and watching planets. They weren't idiots, right? And these folks came along and did something different. And we're going to see why that is. Okay. These folks believed that the Earth was the center of the universe. Okay. These folks did not. They believed that the sun was the center of our solar system. They didn't know about other solar systems, but we're not going to get into that. Okay. All right, so here is an ancient Greek model, and you can tell that it's got this Earth at the center, and then it's got all these funny little rings as you go out. Some of them you can't read and only I can read, but I'll tell you what they say. So at the very edge, that's the zodiac. That's like the exterior ring. That doesn't appear to be moving to the Greeks. And then you have something out here called Saturn. Remember, we said that that's been known since antiquity. So for 6,000 years, we've known about Saturn. And so that's the outest ring, the farthest ring. That's how they interpret it. They said the Saturn must be there. This then becomes, what's the one closer than Saturn? Jupiter. And you can read it there if you can read Greek. And then the one after that, Martis. What is that? Mars, right? Martis, remember? And then this one's Solus. That's a weird one. I've never heard of that planet. That's the sun. Okay, so the sun was actually in between Martis and whatever this word is. Venus. I can't remember it, and I know it is. And then the Mercury and the moon. Okay, so that was their mental model for how the solar system was constructed. They are among the first people. I showed you many examples of people who made models of the solar system. But what they did here is they tried to explain it by patterns and rational thinking. They tried to codify it. They tried to say, if this means this, then this has to come logically from that, right? So the idea of I can create some test, and if it fails the test, then it's not a good explanation. And they said, we're not going to accept any reason that's based on, well, it feels that way, right? Yeah.
Extra yellow on the front filter.
Oh, good question. Oh, comments. Yeah. Weird stuff they saw in the sky. Okay. We don't have time to do this clicker question, so I'm gonna skip it. There was a reading question. Y'all did the reading, right? Sure. You're gonna do it next time, right? Yeah, sure. All right. Sure. All right. So how did they explain planetary motion? Well, they said it's very easy. You know, the fact that you don't know this is crazy. I mean, Earth's obviously at the center. Like, I don't feel like I'm moving. You don't feel like you're moving. So we can all agree on that. But they also said that the heavens had to be perfect. You saw previously, those are circles, right? Circles are beautiful. They're everywhere. Moon, circle, obviously. So everything moves on perfect circles, and that explains it all. Circles, circles, circles. Okay? And Plato said that, and his student was like, yep, that seems reasonable. And can we make a model that describes the motion of everything we see in the night sky based on circles? Perfect circles, because the heavens should be built perfectly. Okay? So they did all this. They saw some observations of these different objects, some that move faster, some that move slower. And they said, well, the ones that move faster, they're probably on a smaller circle. And the ones that move slower are on a bigger circle. Great explanation, right? Okay. But now they got a problem. Okay. So they're like, what the hell? Okay, so sometimes if you take really, really careful observations, you see that Mars, for example, is moving across the night sky over like a couple months, and then it turns around, goes the other direction, and then it turns around again and goes this direction. Okay, and they're like, well, that is not a perfect circle, right? So how do you explain that? That's good. Yeah, oh, good.
Is it not because it's like I think it was like how you tell children.
Well, no. So that's the real reason.
Okay.
That's what but we don't know that.
Okay.
Right? We currently believe, the whole class believes, because we're in ancient Greece right now. We currently believe that the Earth is the center of the universe. And an astronomer comes down and says, bro, like Mars has been doing some weird stuff recently, just turned around. Right? And you're all tasked with explaining it with perfect circles. No. We can't invoke something that isn't part of our perfect circle plan, right?
With a circle on circle, so it keeps moving.
Circle of circles. Okay, interesting. Yeah, this is called an epicycle, or a circle on a circle. And this is what Ptolemy is famous for. Said, just put a circle on a circle. You know, like you put a bird on it, put a circle on it. And that worked perfectly. So we don't have to abandon the Earth-centric view, it works for all of the planets, just as long as you put a second circle on the big circle. And that explains why it turns around. Now, why there's a second circle? Don't get it, okay? But it works, right? So the model works, so therefore it must be right. Right? Still geocentric. Boom. Okay. They considered the currently explained explanation, or the currently accepted explanation. They thought about, well, what if we're not the center of the universe? What if we're not the center of the solar system, you think? But they said there's no evidence to suggest that Earth is not the center. That is to say, there's an abundance of evidence to suggest that the Earth is the center. And the main reason for that, right, doesn't feel like we're flying through the solar system. Good, that's a great one. But also, they were looking at the night sky, that all these observations, and you notice that I've been making laps of this thing. And you notice that when you look at me, my background is changing. Right? And similarly, you in the front move more than those in the back. Okay? This is called parallax. Okay? This is like when you move around, you notice stuff at different distances appears to move. Well, they would watch night after night after night, and none of the stars would move. Right? So if that's the case, then we can't be moving either. Does that make sense? That's a perfectly rational argument, right? Okay. How'd they get it wrong? Yeah.
Greece was, it's because where Greece is on the planet, that the stars look differently at night.
Greece wasn't alone. Remember, we're highlighting the Greeks here, but the whole world got it wrong. Chinese astronomers are doing this too. Yeah. I wish that were true. No, but they would have arguments, right? They had like really, I mean, so you have groups of people who think one thing and groups of people who think another. And of course, you benefit in science when they compete because they're trying out new ideas. So they're trying to prove the other wrong. Right? And they had all this evidence that the stars were not moving. Yeah.
They didn't do any experiments.
Well, no, they had the observations. They would go out and they'd look for stars and see if any of the stars moved. And none of the stars appeared to move to them. Okay. Have you ever done this with your example of parallax? You take the thumb, hands and thumbs, I don't know. Anyway, so just close one eye and watch that your thumb moves back and forth, right? So nearby stars should move throughout the course of the year, because if we're moving around in a circle, then we'll get closer to some and farther from some, and they'll appear to wobble back and forth, right? Okay. So they said that they couldn't see any motion, right? They would want to see something like this in January. Nearby stars here should move compared to like July, right? And let me just ask you this question. We're going to do one clicker question, okay, and then I'm going to let you go. How would a star's parallax change? Actually, we're going to do two clicker questions because I forgot about the one at the end. Okay, how would a star's parallax change as the distance from the Earth increased? And I'll give you a hint. You can use your hands here, but wait for me to finish talking. A, the star's parallax, how much it shifts back and forth, would increase as the star moved away from the Earth. The parallax, how much it moves back and forth, does not change. It's independent of the star's distance. Or the parallax, how much it moves back and forth, would increase as the star moves towards the Earth. Yeah, exactly right. You don't have to think it through, you can experiment.
So, you know, like.
All right, 46. Okay, so if everyone has done this, as they bring it in, which one has the larger parallax? Closer. The closer you are, the more that it moves compared to the background. Yeah. So exactly, it's C. Good. So here's what they said. They measured the parallax of the stars. They didn't see any. And they said this means one of two things. Either the stars are so far away that it's too difficult to see with the naked eye. That's not possible. How could that possibly be true? Or the Earth doesn't orbit the sun. Obvious. Because we don't feel like we're moving, and we have this evidence. Okay, wait, now before you leave, okay, let's just ask this one question. Here are the rest of the times. How many of these can you make? These are the student help sessions. So I posted this on Canvas, and it includes the location and the day and who it's with. And this is if you attend one per signed in, you get that extra credit. So I just want to make sure that folks can attend, because if we get a lot of nuns, then I'll have to add more. Okay, and if you did finish the lecture tutorial, please bring them up here. If you have a homework that it wasn't collected, please bring it up here.
For the worksheets?
Yeah. If they're not finished, keep them and finish them. You have your. So that is posted on the Facebook for the observatory, and also the there's an Instagram as well. But we will send out updates. I can put them in the content calendar if you want. So yeah, free. Yeah, and it's free to anyone too. So if you want to bring like family or friends. Cool. Yeah. I know. But you don't have them.
You know the, like, you know the chair?
The what?
Like the chair